My name is Jessica Fay and this is my presentation for assignment number 14, Atomic Structure and Bonding. In this presentation I will explain the topics which arise in scenarios 3 and 4. I will explain ions and ionic bonds with examples. I will explain covalent bonds and how they're formed, and I will identify 4 examples of molecules with covalent bonds and showing diagrams that I have drawn. So here's the first abstract. Atmospheric ions are electrically charged particles which occur naturally in the atmosphere. They form in the upper atmospheric layers, mainly because of the action of ultraviolet radiation from the sun, as well as in the lower atmospheric layers as a result of radioactive radiation and cosmic rays. These cause ionization of neutral molecules or atoms. As a result, ions are formed. These ions almost instantaneously combine to form molecules with ionic bonds. So what are ions? Ions are atoms or molecules which have lost or gained electrons, giving them an overall electrical charge, either positive or negative. So here's a neutral atom. If you lose electrons, you become more positive, and that makes a cation. If you gain electrons, you become overall more negative and you become an anion. But both of these are ions. So atoms are generally neutrally charged, meaning they have balanced numbers of electrons and protons. Ions can be dangerous to cells, but they're also advantageous to us. They're used in mass spectrometry, which allow us to learn about planets, and they're used in fluorescent lights. Examples of ions. Seen here is a neutrally charged sodium atom. When energy is given, this can remove an electron, which then creates a slightly positive ion of sodium. This electron can be taken up by an atom such as the chlorine atom. Because there are 7 valence electrons, it can gain an electron, and that results in a slightly negative ion of chlorine. Okay, that's that for that one. Types of bonds between atoms. Atoms can be bonded together to make compounds, usually to make them more stable. The most common example is probably sodium chloride, or what we know as salt. The main types of bonds are ionic, covalent, polar and hydrogen. We are going to look more closely at covalent and ionic bonds. But the octet rule says that atoms are most stable when they have 8 electrons in their outermost shell. So ionic bonds. These form between metals and non-metals. They're also known as electrovalence bonds. They form because of the difference in electronegativity between the atoms, and it's usually when there is more than 2 in the difference of electronegativity. They form between 2 or more atoms to make compounds. Metals are electropositive and tend to lose electrons, whereas non-metals are electronegative and tend to gain electrons. Ionic bonds involve the transfer of electrons, resulting in a cation and an anion. Examples of some ionic bonds. You can see here there is a sodium atom, has 1 valence electron in the outer shell. When that is near a chlorine atom with 7 valence electrons in its outer shell, that transfer of electron is quite willingly taken up by the chlorine to produce a chloride anion, and the loss of the electron here to leave a full outer shell for the sodium, resulting in a cation. Both sodium and chlorine will be more stable if they transfer this electron. And once the electron has been transferred, sodium has a charge of +1, because it's lost 1 electron, and the chloride ion will have a charge of -1 because it's gained 1 electron. When more than 1 electron is transferred to fulfill the outer shell, the ions will have a different charge. So an example would be magnesium and oxygen. So when magnesium reacts with, or bonds, with an oxygen atom, because the oxygen atom has 6 valence electrons and the magnesium atom has 2 valence electrons, those 2 electrons will be taken up by the oxygen atom to produce a full outer shell for the oxygen, resulting in an oxide ion with a charge of 2-, whereas the magnesium is happy to let those 2 electrons go because then the inner shell will be its outer shell and it will be full, and resulting in a 2+ charge and a magnesium cation. The second abstract we've got is a polymer is a substance which has a molecular structure comprising of a large number of identical molecules covalently bonded together to form a long chain structure. Many synthetic organic materials are polymers such as nylon, polyethylene and Kevlar. So covalent bonds, these bonds involve sharing 1 or more electrons to try to fill the outer shells of each atom to achieve stability, so rather than transferring of electrons. They form between nonmetals, either 2 or more of the same atoms, for example H2 with 2 hydrogen atoms, or O2, 2 oxygen atoms, or between atoms of different elements, for example CO2, which is carbon dioxide, or H2O, which is water. Oh, sorry, I'll go back to that one. So it's possible to have single, double or triple covalent bonds. Covalent bonds involve a single electron shared by each atom, and you can also have dative covalent bonds, or coordinate covalent bonds, which involves 1 atom sharing 2 electrons from the other rather than 1 each. So here, this is just an example of a carbon and a carbon with hydrogens. So my example for a single covalent bond is ammonia, so that is NH3. So the diagram shows the nitrogen atom with 3 covalent bonds to hydrogen atoms to make ammonia. The nitrogen's outermost electrons are represented by the black circles, and the hydrogen's outermost electrons are represented by crosses. You can see the sharing of an electron per atom per bond. Now this is an example here, NH4, of a coordinate or a dative bond. So when ammonia becomes bonded to a hydrogen cation, you can see it is using both of the electrons from the nitrogen rather than 1 from hydrogen, 1 from nitrogen. These are both the nitrogen's electrons. A double covalent bond, formed by sharing 2 pairs of valence electrons. These are moderately reactive, and the bonds are shorter and stronger than the single bonds. The example here is O2. The 2 lines here represent the double bond, and you can see this is 1 pair, this is 1 pair, so there are 2 pairs here. 1 electron from the oxygen, and 1 electron from this oxygen, 1 electron from that one, and 1 from this one again. That results in the full outer shells for both atoms. So a triple covalent bond here. So bonds involve the sharing of 3 pairs of electrons. This is an example of N2, 2 nitrogen atoms, and the triple bond is represented here by the triple line. These are highly reactive, one of the most unstable covalent bonds. And thank you very much for listening.